Okay guys, here's our first part of inscribed angle notes. Okay, we've already gone over central angles, angles where the vertex is on the center of the circle. Now we're actually going to be talking about inscribed angles where the vertex is on the circle. Okay, so that's our first part there. Again, inscribed, the vertex, the angle itself is on the circle. Okay, so example 1 here would be an example of an inscribed angle. We're also going to be reviewing central angles as we go through this, but just kind of stay with me till we get there, okay? So here, our name of our inscribed angle, again, we're using the 3-letter naming method here. So JED would be the angle we're talking about, angle JED. And the intercepted arc, again, we're thinking about the angle like an alligator mouth. It would be the piece of the circle that alligator mouth chomps off, okay? So again, JD, arc JD is what we were talking about there. And again, we write that arc has a little rainbow above our 2 letters showing you that it is an arc, not a line segment. It is a piece of the circle itself, okay? So inscribed angle JED intercepts arc JD, okay? Now we're going to be talking about what that does to the angle measure and the arc measure here in just a second, all right? Now next we have what's called an inscribed triangle, okay? So this would be an inscribed polygon in a circle. Here it's a triangle because it has 3 vertices, 3 line segments. It's a triangle, okay? So the 3 inscribed angles, okay, and their intercepted arcs. So I'm going to do the angles and then their intercepted arcs. So we'll start with the one we just did, okay? You see we just added line segment JD here, all right? So we're going to talk about angle JED, which we already know, intercepts arc JD, okay? Arc JD. Now let's look at the other ones. Here we have JDE, this angle up here in the top right, angle JDE. Okay, so again, JDE opens up to arc JE, would be its intercepted arc. And last but certainly not least, we could say we have EJD, the top left angle, angle EJD, okay, and that would open up to arc DE or ED, okay, arc ED. So each angle opens up to its own intercepted arc, guys, okay? That's going to be very important. Now, last one we have here is an example where we have a secant and a tangent, okay? So we have a line that hits it at one spot, a line segment, or I guess you could call this a chord. A secant line would keep going. A chord would be like chord JE and then tangent line ED. A chord and a tangent also form an inscribed angle, guys. So again, that vertex right there is still on the circle. So here in a second, the same rules are going to apply, and we'll do examples of all these, okay? All right, so we have an inscribed angle, an inscribed polygon, and an inscribed angle created by a chord and a tangent line, okay? All right, now let's look at some examples here, y'all. Again, I'm going to try to keep this in frame for y'all, hopefully do the best I can. So here we go. We're looking at the measures of inscribed angles. The measure of an inscribed angle is half its intercepted arc. And yeah, guys, it is that easy. You just divide by 2, okay? Here in a second, we're going to talk about how that looks like compared to central angles. But on this first one, we have, again, the example, our angle JED intercepting arc JD. And you're going to see me kind of drawing this squiggle to show which arc's been intercepted. So because the arc is 80, that means the angle itself all the way down here is going to be half, which is 40 degrees, okay? And yeah, it is that easy, guys, okay? In example 5, we have an example where we have a central angle and an inscribed angle. So here we're comparing the 2. Now, we notice that both JCD, the central angle, it intercepts arc 120 with a measure of 120, arc JD. So again, central angle is the same. That's 120 degrees because its vertex is at the center. What we're talking about today, the new stuff, is the inscribed angle JED, vertex is on the circle, that's half. That's where we get 60 degrees from, okay? 60, again, if you want to write 120 over 2, just to help you remember, we're dividing by 2. Sorry, I lost my paper there for a second. Okay, so example 5, we have a central angle and an inscribed angle. Again, the central angle is the same. The inscribed angle is half. That's where we get 120 and 60 from, okay? Now here we have an example of, again, a chord and a tangent, okay? Now it gives us the information that measure of arc JOE is 200. Again, we use 3 letters because this is a major arc. It is greater than 180, bigger than half the circle, so JOE is 200 degrees. 200 degrees. Now let's think about this, guys. If we still treat this angle like an alligator mouth, if it snaps shut, it's going to take out this whole piece of the circle. That whole arc, that big arc, is still inside the angle. That is the intercepted arc, okay? So when we find the measure of JED, we still just divide by 2, y'all. So measure of angle JED is 100 degrees. That angle right there, 100 degrees, okay? All right? It's a little different looking, but the rule stays the same. Whatever arc is intercepted, whatever arc is in between the 2 rays, or here it'd be a chord and a tangent of our angle, think about it like the alligator mouth. When it snaps shut, it's going to bite off this whole piece here. That's what we're dividing by 2 to get 100 for our intercepted arc. Now the last little portion of this, it asks us for the measure of arc JE. Well, that's just what's left over. If the whole thing is 360, that's the magic number with circles as far as degrees go, we already had 200, then the leftover portion is just going to be 160 degrees. Again, if you want to write 300 minus 200, 360 minus 200, there we go. That's where we get 160 degrees from, okay? All right, so that's just the leftover of the circle. All right, last little piece here, guys. We have an inscribed triangle. Again, a triangle with 3 vertices on the angle itself. It asks us for the measure of angle DJE and the measure of arc DOE. Now, it doesn't give us any angle or arc measures, but the piece it does give us that's extremely important, which you always need to be watching out for, is this line segment right here. This is a diameter, guys, okay? Whenever you see a line going through the center that hits on both sides, that is a diameter that automatically splits the circle into 2 semicircles. So over here is 180, okay, and then the same thing on the other side. Now, we look at this. We see measure of angle DJE opens up to each side of the diameter, okay? So this whole intercepted arc is what we're talking about. So 180 divided by 2, that's where we get 90 degrees from, okay? We just divide by 2. The intercepted arc is 180, so the angle itself is 90. That is a right angle, okay? Now the measure of angle arc, DOE, that's what we just talked about. We already solved for that just by knowing that DE is a diameter. That means arc DOE is a semicircle, so that is 180 degrees, okay? All right, now guys, number 8 is a create your own problem. We're not going to do that right now. We're going to keep moving. All right, so in your own words, you're going to move on to number 9. In your own words, describe what an inscribed angle is and how you solve for its measure. Okay, so kind of an overview of what we already talked about. Now, an inscribed angle, all right, an inscribed angle is an angle in a circle with its vertex on the circle. So if you just want to write vertex on the circle, okay, and again, it's said in my own words, so I'm not going to write complete sentences. I'm just going to write what's an inscribed angle, vertex on the circle, and how you solve for its measure. Solve for its measure, half the intercepted arc. Okay, so not complete sentences there, but guys, what's an inscribed angle? Angle with the vertex on the circle. How do you solve for its measure? It's half its intercepted arc, okay? All right.